students, I welcome you all for our lecture series on food technology. In today's lecture, let's make an attempt to know about flavor. The appearance of a food is an important aspect, but the flavor of a food is the feature which determines the overall quality and acceptability of foods. A food can get rejected based on the flavor only, even with an acceptable color, safety and nutritional value. Flavors exert an important effect on food choice even without any nutritional significance of theirs. Knowledge of flavor is perceived to be a recent development in food chemistry that occurred due to the invention of techniques such as gas chromatography and mass spectrometry. Food chemistry involves study of compounds derived from foods among an extremely wide range of chemical structures that are able to generate a response from the sensory receptors, producing a psychological response. The following aspects will be covered in this chapter: 1. Definition of flavor, 2. Basic tastes, 3. Chemical structure and taste, 4. The smell sensation, 5. Visual appearance, texture and flavor, 6. Description of food flavors, and 7. Flavor enhancers and flavorings. Let's start with the first topic. Now let's learn about the definition of flavor. The classic definition of flavor as defined by Hall 1968 is: flavor is the sensation produced by a material taken in the mouth, perceived principally by the senses of taste and smell, and also by the general pain, tactile and temperature receptors in the mouth. Flavor also denotes the sum of the characteristics of the material which produce that sensation. From this idea, we can understand that flavor is a property of the food substance as well as the flavor sensing mechanism in an individual ingesting the food substance. Thus, the study of flavor includes the composition of foods in terms of compounds having a smell or taste, and the process and outcome of interaction between these compounds and the component of an individual's taste and smell sensing organs. The understanding of flavor of a food originates when the signals produced by the sensory organs reach central nervous system. Flavor is mainly composed of taste and odor, but is also influenced by other properties such as texture, appearance, pH of the food, etc. Flavor is one of the sensory phenomenon experienced based on the taste, odor or smell, appearance, texture, temperature of a food that can trigger the senses. Flavor of a food is a result of interaction between the components present, and these are commonly non-nutritive and have the ability to induce the sensation at very low concentrations. Now let's move on to the next topic: basic tastes. The complex interaction between the senses used to judge a food based on its appearance, smell, touch and hearing results in a decision to ingest or to reject a particular food. This interaction is commonly referred to as taste. There are 5 basic tastes, which are sour, salty, sweet, bitter and umami. These taste qualities are mediated to the central nervous system through specialized epithelial cells known as taste receptor cells, located in the taste buds, thus providing different anatomy to the 5 basic tastes. The taste buds mostly are distributed within the papillae of the tongue and to a lesser extent in the palate and epiglottis. The perception of the basic tastes is known to be the outcome of a pattern of nerve activity from many taste cells in the tongue. The 5 tastes can be perceived at any area of the human tongue, although the intensity of the perception may vary based on the region of the tongue and the type of papilla. For instance, sweet taste of saccharin is felt highest at the tip of the tongue, whereas the taste of bitter quinine is perceived best at the back of the tongue. The taste buds are innervated by the 7th, 9th and 10th cranial nerve. Recent advancement has led to the identification of the receptors for taste and their functional properties. The 5 basic tastes are dealt further in detail. 1. Sour taste. The sour taste is recognized as a property of the hydrogen ion, but the response is not proportional to the pH of a food. Thus, acids can give rise to perception of different levels of sour taste. The sourness perceived depends on the nature of the acid group, pH, buffering effects and presence of other compounds such as sugars. At the same pH, organic acids have a greater taste effect than inorganic acids such as hydrochloric acid. The most common acids found in foods are tartaric acid, malic acid, phosphoric acid and citric acid. The presence of buffers can increase the sourness of weaker acids. Partially neutralized acids are known to have more sourness than its pure form. Alcohol in foods is known to reduce the intensity of sourness as seen in wine. The second taste, salty. So, the salty taste is best perceived by sodium chloride or table salt. Salts have different taste depending on the nature of anions and cations. Increase in molecular weight of these ions can make the salt taste more bitter. Sodium chloride is known to enhance the mouthfeel, sweetness, saltiness and has the ability to mask the off flavors. Such an action is not seen in other chloride salts such as potassium chloride. The next taste is sweet. Compounds in food that have a hydroxyl group, imine or amine group or methane group are known to produce a sweet taste. Examples of such compounds are saccharides such as sucrose, glucose, maltose, sweeteners such as saccharin, sorbitol, stevioside and D-isomers of valine, serine, histidine, etc. The next taste is bitter. The bitter taste in many foods can be due to a variety of inorganic and organic compounds. Although considered to be an unpleasant taste, bitterness is a part of other tastes such as sweet and sourness. Inorganic salts such as potassium iodide, amino acids like leucine, arginine can taste bitter. Alkaloids and glycosides are compounds identified best for their bitterness. Quinine, caffeine, theobromine are some of the alkaloids seen in various foods and food products. Quinine is also used as a standard for testing bitterness of other foods. Naringin, an alkaloid found in citrus fruits, contributes to the bitter taste. Peptides formed by partial hydrolysis of proteins, as seen in cheese or dairy products, also results in a bitter taste. And the next taste is umami. Umami is a Japanese term used for this type of taste, which means delicious flavor. It is also referred to as savoriness and the taste sensation produced by the free glutamates found in food. This sensation is further increased in the presence of sodium as seen in tomatoes. Monosodium glutamate is an additive with a strong umami taste. The basic tastes themselves cannot completely describe the taste of a food without considering the interrelationships between them. For instance, sugar-acid ratio plays an important role in many foods, especially fruits, fruit juices and wines, deciding their flavor quality. There are many factors that can affect the sense of taste of a compound or food. Temperature, for instance, can vary the perception of taste significantly. A sugary drink may taste sweeter when it is hot than cold. Lemon drinks can taste more sour when hot than cold. Cold tea and coffee taste more bitter than hot. Such variations may arise due to the changes in the sensitivity of the taste buds to the temperature. Other factors that affect taste are individual variations among people, mixture of more than one taste quality, and concentration of compounds in foods. Now let's learn about the chemical structure and taste. The interrelationship of chemical structure of a compound and taste is more pronounced than with smell. All acids in general are sour, sodium chloride and few other salts are salty. However, as atoms get bigger, the bitterness increases. For instance, potassium bromide, which is both salty and bitter. Sweetness is exhibited by sugars, lead acetate, beryllium salts, and artificial sweeteners such as saccharin and cyclamate. Bitterness is a property of alkaloids such as quinine, picric acid, and heavy metal salts. Changes in the chemical structure, although minor, can cause a change in the taste of compounds. Saccharin, for instance, is 500 times sweeter than sucrose, but the introduction of a methyl group or chloride ion at the para position reduced to half. Some of the amino acids are known to have a bitter taste in their L configuration and a sweet taste in their D form. L-tyrosine, for example, is about 20 times less bitter than caffeine, and D-tyrosine, which is 5.5 times sweeter than sucrose. The next topic is the smell sensation. The role of odor or smell is important in many flavors. Smell is recognized by olfactory cells, a type of receptor cells found on each side of the septum in the upper nasal cavity. Any molecule with an odor on passage through the nasal cavity stimulates sensitive hairs that communicate with the brain, resulting in perception. Odors are usually the result of the presence of mixture of several compounds. The combined odor of these compounds seen in many natural and artificial foods may be different than the odor of individual molecules. Odors are described by two aspects, namely threshold value and odor quality. The threshold value is defined as the lowest concentration of a compound that creates a perception of odor, and the odor quality describes the characteristics of the aroma. The primary odors felt by humans and the compounds responsible are shown in table number 1 on your screen. There are many kinds of primary odors such as camphoraceous, which is produced by bonniol, tert-butyl alcohol, D-camphor, cineol, pentamethyl ethyl alcohol. Pungent odors are a result of allyl alcohol, cyanogen, formaldehyde and formic acid. Floral odors are a result of benzyl acetate, geraniol, phenyl ethyl alcohol and terpineol. Pepperminty odor is due to tert-butyl carbinol, cyclohexanone, menthone and piperitol. Putrid odor can be due to amyl mercaptan, cadaverine, hydrogen sulfide and indole. The next topic is visual appearance, texture and flavor. The willingness to accept or reject a food primarily relies on the appearance of the food. Through experience, An expectation about the odor, taste and texture of a food can be made based on the appearance. Appearance of a food is dependent on the way a food is presented, optical properties which includes features such as color, gloss and translucency, physical form of food which consists of shape, size and visual viscosity. The textural aspects of a food also contributes to its flavor. There are primary and secondary textural aspects that contribute to food acceptability and taste. Hardness, cohesiveness, viscosity and elasticity are primary aspects, whereas chewiness, brittleness and gumminess are secondary aspects. Overall, the color, odor and texture are known to contribute individually to the flavor of a food, but the overall sensation of flavor depends on the interactions of all these aspects in the mouth, which is also known as mouth feel. The interrelationship between the innervated tissues of the mouth, nasal cavity and throat creates this perception. Let us move on to the next topic, which is description of food flavors. Flavors are often used in training individuals on the basis of widely recognized taste and smell sensations. The optimum and precise description of flavors is crucial for food developers, as it is the basic skill required to create new food products. Primary, secondary and tertiary words are used to describe each flavor. For example, juicy, sweet, peely and other adjective words are used to describe the flavor of an orange. The primary word used is orange and the other words such as juicy, sweet, peely are secondary words. Let us now consider an example of an orange with a higher sweet taste and with a little juicy feel. It can be described as follows: the primary word being orange, the secondary word being sweet and the tertiary word being juicy. A series of the primary, secondary and tertiary words used for describing flavor are shown in table number 2 on your screen. Lemon is a primary word and the secondary and tertiary words used are juicy, fresh, oxidized, oily or candy. Coffee, for example, has the following secondary or tertiary words: roasted, brewed, sweet, vanilla-like, bitter, fresh and instant. Cola has the following secondary and tertiary words: spicy, citrus, woody, oxidized and vanilla-like. Apple, for instance, has the following secondary or tertiary words: red, green, peely, juicy, delicious, fresh and ripe. Vanillin, hay-like, creamy, French and extracted are the secondary or tertiary words used to describe vanilla. Ripe, green, candy, cooked and spicy are the words used to describe banana. Juicy, perfumed, candy, cooked and ripe are the words used to describe blueberry. Juicy, ripe, green, floral and skinny are the words used to describe mango. Juicy, ripe, canned and candy are the words used to describe the primary word pineapple. Let us move on to the next topic, flavor enhancers and flavorings. Flavor enhancers are compounds that are added to a food with an intention to supplement or increase the basic flavor. They are used widely in foods and beverages and are found in both natural and synthetic forms. In Asia, cooks practiced the addition of seaweed to to soup stocks which increase their flavor. This led to the origin of use of flavor enhancers. L-glutamate was identified as the flavor compound in seaweed. Further, monosodium glutamate or MSG became the first flavor enhancer to be used commercially. The rich flavor associated with L-glutamate was called umami. Examples of compounds used as flavor enhancers include the 5-ribonucleotides, inosine monophosphate, guanosine monophosphate, yeast extract, and hydrolyzed vegetable protein. Flavor enhancers may be used in soups, broths, sauces, gravies, flavoring and spice blends, canned and frozen vegetables, and meats. Flavor enhancers are labeled on food ingredient packets with unique E numbers ranging from E600 to E699. E numbers are codes for substances that are permitted to be used as food additives in the European Union and Switzerland. Some of the flavor enhancers used in foods along with their E number is given in table number 3 on your screen. Glutamic acid has an E number of E620. Monosodium glutamate has an E number of E621. Calcium glutamate has an E number of E623. Ammonium glutamate has an E number of E624. Magnesium glutamate has an E number of E625, whereas E629 is the E number for calcium guanylate, E630 for inosinic acid, E631 for sodium inosinate, E633 for calcium inosinate, E634 for calcium ribonucleotides, E636 for maltol, and E637 for ethyl maltol. Let's move on to the next topic, flavorings. Flavorings are products added to a food in order to add or modify the odor and taste. A flavor additive can be a single chemical or a blend of chemicals which can be of natural and synthetic origin. Overall, flavorings produce flavor partially or completely on addition to a particular food. They are often added with an intention to replace the flavor which is lost during processing as well as in new product development. More than 1200 compounds are used commercially. They are not represented by E numbers. Instead, their use is controlled by food laws of respective countries, as some of them possess health risks. Natural flavorings are derived from plants, spices, herbs, animals, or microbial fermentations. Artificial flavorings are mixtures of synthetic compounds that appear to have identical chemical properties compared to natural flavorings. Natural flavorings are used less often due to their high cost, lack of availability, or less potency. Based on their origin, the flavorings are classified into 3 categories. 1. Natural flavoring substances obtained from plant or animals by physical, microbiological, or enzymatic processes. Examples: spices, fruit juices, herbs, vegetable juice, etc. 2. Nature identical flavoring substances are obtained by synthesis or extracted, which have a chemical structure identical to the substances present in natural products. Example: vanillin, which can be produced as a natural or a nature identical substance. And 3. Artificial flavoring substances, which are substances with no equivalence in nature and are produced artificially. Example: ethyl vanillin, which is artificial and smells and tastes like naturally occurring vanillin. Some of the commonly used chemicals in food flavorings are shown in table number 4 on your screen. The chemical allyl pyrazine gives a roasted nut flavor. Methoxypyrazines give earthy vegetable flavor. 2-isobutyl 3-methoxypyrazine are known to produce green pepper flavor. Acetyl L-pyrazines give popcorn flavor. 2-acetoxypyrazine gives toasted flavor. Aldehydes produce fruity green flavors. Alcohols produce bitter or medicinal flavor. Esters produce fruity flavor. Ketones produce butter or caramel flavor. Pyrazines produce brown or burnt or caramel flavor. Phenolics produce medicinal or smoky flavor, and terpenoids produce citrus or piney flavor. Thus, we can conclude that flavor of a food has an important role in food choices than taste, color and texture alone. The ability to sense the 5 basic tastes are responsible for the chemical stimulation resulting in perception. Compounds in food have a large impact on the overall flavor of a food, and this effect can change with alterations in physical and chemical attributes. The importance of flavor of a food has given rise to the research and use of many natural and artificial flavor compounds with an aim to boost the acceptance of a particular type of food in the targeted population. Thank you.